So we can kind of go ahead and get started. So my name is Steve Mills. I'm a mechanical engineer at Facebook, and I lead the Rack and Power project for Open Compute, along with Caleb Lusk. Caleb, you want to introduce yourself here real quick?
Hello, everybody. Caleb Lusk with Rittal. I'm a mechanical engineer. 17 years now with the company, and I am a co-chair with Steve on Rack and Power. Just recently added, so yeah, a newbie.
Thanks, Caleb. So the goal for today, right? This is supposed to be more of a working session, right, as opposed to a presentation session. So tomorrow afternoon, I'll be giving kind of an overview of where the project is at. If you guys are new and interested in getting involved, there'll be kind of an overview of where we are right now and kind of where we're trying to get to in the future. Tomorrow afternoon's session, I believe it's at 4 o'clock in the ACS track. So for today, I can give a real quick brief. So we kicked this sub-project off. It's kind of in the middle of the summer. We've been meeting for the last couple of months. So we have gone through and developed our charter, which describes kind of the scope of the work that we're going to be doing. And we are now kind of in the process of, well, we've gone through the process of defining the different work streams for within the Advanced Cooling Solutions sub-project. So we chose to break it up into kind of 3 different work streams. We've got one based on direct cooling. We've got one based on immersion. And then we've got one that is a door-based heat exchanger system. So those are the kind of the 3 main topics for the time being. And then the teams have kind of gone through and we've added specific projects within each of those work streams. So specifications within each of those. So the kind of the goal for today is to first kind of introduce the leadership right now, since most of us, this is the first time we've actually been meeting in person. And then the kind of the next steps is kind of break up into kind of 3 different work streams. The direct cooling, immersion, and the door heat exchanger. And then from there, kind of go through the list of projects that have been developed, and we'll kind of prioritize each of those. And then from there, we'll kind of divvy up the work, right? We'll try and see if we can get some people that are interested in working on those different projects, and then we'll hopefully kind of self-organize around those and work on specifics of what each of those are, and kind of some rough goals and delivery dates, those kinds of things. So that's the plan for today. So those of you that are new to the project, this will be some catching up, but we'll have a little bit more history tomorrow in the formal sessions. So my role in this as along with Caleb, right? So we're the project leads for Rack and Power, and then this ACS, the Advanced Cooling Solutions, falls underneath Rack and Power right now. So for Advanced Cooling Solutions, we have 3 volunteer leads, 1 for each work stream. So I'll invite them up right now. So the first one is Austin Shellnut from Dell. He's not able to be here today, so I'll be standing in for him today. And then we've got Rolf. You want to come up and introduce yourself? So Rolf's going to be leading the immersion stream.
Hi. Yes. My name is Rolf Brink. I'm from Asperitas, and I'll be engaging together with Steve on the advanced cooling stream. Towards immersion technology. The workstream is going to be focused on the interface layers of liquid solutions towards data center infrastructure. but also towards best practices relating to immersion technology and optimizing service systems for immersion technology. The first conversations are going to be taking place today, I guess, and be sure to join them.
Yeah, absolutely. I wrote that one down on it. All right, so Jacob, do you want to come up? So Jacob's going to be leading the door heat exchanger workstream.
Hi, my name is Jacob Na. I'm working at Facebook. So I'll be leading on door heat exchanger. So this is more like an in-rack type of liquid cooling. So probably well known as a hybrid cooling solutions. So I will be looking forward to working with everyone to define the specification for OCP.
And so the direct cooling right now is going to be mainly the direct contact work stream is going to be looking at kind of the interfaces between the rack and the data center, as well as the interfaces between the IT gear and the coolant system. And one thing you'll see across all of these work streams is attempt to be consistent across there. There's going to be a focus on materials, wetted materials, and then for a larger set of that, or I guess maybe even a smaller subset of that, would be the materials that are compatible with immersion. Since much more of the components inside the IT gear comes in contact with the immersion type solution. All right, so have you been able to pull up kind of the different work areas? So again, this is going to be kind of a working session, right, as opposed to presentations, but we can show you some of the details right now for those of you who haven't gotten a chance to get involved yet. Yeah, no problem. So this, what we've got right now is just kind of our first pass, right? So the scoping document that we've got is just what we're working on right now. Just like any other projects, it can evolve over time as we add and delete different things that are no longer priorities. And then what you also see is the, again, kind of the first pass at the work stream. Some of these, this is just where we've gotten so far in the last couple of months. Would you go ahead and kind of scroll down to the different streams at the bottom? So this is a collaborative document. This isn't something that I wrote. The first pass is actually written by Bill, the CTO, Bill Carter. And since then, the project team has been involved in editing the charter, and then as well as the work streams down here. So yeah, if you kind of go through the cold plate work stream or the direct contact. So this is one I'll kind of be focusing on today. So at this point, all we have is kind of an outline of the different areas that we're going to focus on. Transfer fluids, quick connect. I think there's one more in there. Yeah, metrology and secondary loop specifications. So the focus of all of these is to kind of identify the interfaces between the componentry, right, and leave as much room as possible for innovation within that. So, while we might look at, we want to go for compatibility between, say, data center architecture and the componentry that's interconnecting with it. So something you'll see kind of across at least kind of the direct contact and the rear door is, whether it's let's say the interface between the rack and the data center, right? The pressures, temperatures, fluids, the mechanical interfaces on the pipe threads, the geometry of that, all that should be consistent ideally between the rack where that's a rear door heat exchanger, or you roll that one out and you roll another one right next to it. That's going to be a direct cool solution, right? We don't want to have to replumb the data center, right? Ideally, you'd have the same requirements that you can push into either of those systems. So that's the kind of level of definition that we want on the solutions, right? We don't want to try and go through and completely specify the entire solution top to bottom. That's where, you know, all the bright people out in industrial, they'll go figure all that stuff out. We just want to make sure that the interfaces are as well defined as possible. Same way with the IT gear, right? We want to be able to take IT gear from across the OCP community, be able to plug it in the same infrastructure, right? So right now we've already got the power interfaces defined, right? So this would be your coolant solution should also have that same type of a specification, so that all the IT suppliers can connect to the infrastructure in the same way. Same whether it's we'll probably have to have different specifications for that, depending upon whether it's a direct cooling solution where you've got some of it based in air as opposed to the immersion solution, right? The immersion solution is going to have to probably have a different interface. So here's some of the details we've got on the immersion stream. So specifications around the tank. Again, you'll notice that we're not necessarily defining the tank itself, right? Just the interfaces between the IT gear and the tank, or the DC and the tank. All of the complexity and innovation that's part of the tank wouldn't be the level of that we're interested in specifying. That's where Asperitas and Submer and the others will bring their expertise. So a lot of the focus of the immersion is going to be around defining an optimal IT gear form factor, because the current one that we have for air works very well for air, but we need to be able to come up with a form factor that works much better for an immersion, right? Being able to pack a lot more gear into a much smaller volume. So let's see what else we've got in there. Yeah, so again, material compatibility and best practices. And then for the door heat exchanger, you see it's very similar stuff, right? It's we're not going to define what's actually going on inside the door. It would just be the interfaces between the door and the data center, and then what kind of pressure drop or inlet outlet temperatures you would expect. So that information can be fed up to the IT gear designers, right? If they know they've got a certain pressure drop for their AI system, right, then they can build that information, right? They can build that into the design so that it works with a compatible rear door solution from maybe several different suppliers that fit with that power level. So these are the three big groups. So kind of as we go forward, we will kind of break up into smaller groups, and then we're planning on prioritizing this work, and then seeing what next steps we can make to get some of these specifications kicked off. So I'll take just a couple of minutes for questions real quick if you've got any on the stuff that I've talked about right now. Yes?
Hi, Steve. Pete Austin from ICT. Is this charter currently final, or is it open to change? Because I'm trying to figure out how we fit into that.
Sure.
And I can't see us quite fitting into any of them.
Okay.
Is there some flexibility still in it?
Yeah, absolutely. So the reason we have the three that are up there, I guess, is that's kind of where that's where the interest has come from, right? So if there's another area, right, we can adjust the stream as long as we've got people that are interested in working on it.
So I guess although we're kind of like an immersion solution, but we don't submerge.
Right.
We're still in
Right.
like one U form factor, so we use manifolds.
Yep.
So I'm kind of thinking we're probably more in the direct but we're still in immersion solution.
Sure. I think so. I agree with you, right? You would probably be more interested, like in working with the teams that are kind of defining the interfaces between your solution and the data center, right? Those interfaces down there, and then also kind of in the direct camp, because you're going to have your blind mate interfaces between the IT gear and your solution. So.
Where the manifolds fit into the open rack.
Yeah, exactly, right? So that would also be kind of in that same stream. So
Whereas we're not going to be, we don't do tanks, right?
right. But I guess yeah, because you would also probably pull, or you might want to get involved with kind of the material specifications, right? Material compatibility on the immersion side, right? So, you're not, nor is anybody limited to just participating in one of these streams, right? I mean, these streams are set up to kind of help each of those streams focus on what they need to do so that we can make progress more quickly. If we all tried to do this all at one time, there'd be a lot of wasted time with areas that one group's not concerned about and another one is. So we've chose to kind of set these up, and we'll have independent meetings focused around each of these work streams as we go forward. And then we'll roll those up into the ACS larger stream, where we'd be more focused on making sure that the specifications are compatible across the different streams. And so that would be a great area for you to participate. Anybody else on what we're doing today? Yeah. Here you go.
Just a question to come up with a metric or scope for the work. Compared to air cooling, there must be a value in doing liquid cooling. So is there a defined cost, challenge, or threshold that should be passed before any of these things become real? Have you defined that?
So no, we haven't defined anything yet, right? You've seen the extent of the work we've done in the last 2 months, right? But there is a specific topic on that. I think a lot of that work would probably be done outside of OCP, though, right? So there's some stuff about best practices, as well as I can't remember the exact wording of it, Caleb. But there is a topic related to the kind of cost-benefit analysis. So it's just a matter of whether that comes from an OCP member or an outside group. And it certainly would be dependent on the particular IT gear that you're trying to put in there, right? If you're trying to say once you get up over 18 kilowatts, obviously you would go to a liquid-cooled solution. I don't think it's that simple. There's lots of parameters that need to be discussed. So,
Okay.
But yes, I agree with you. Anybody else? Yes.
Yeah, so it's mainly of just making sure that the different work streams afterwards won't be meeting at the same time, so there's an opportunity to be part of several.
Yes, absolutely. We'll have to make sure that we coordinate so that they're running on different schedules. And also that would be a different schedule than kind of the main project. So what we kind of originally decided was that each of the streams can kind of set their cadence and time at the best work for them based on the scope of the work that they need to get done. And then the larger ACS project team would probably meet every 4 to 8 weeks. As things bubble up, we can review those at a larger level, and then from there we would push that up to the incubation committee. But yes, absolutely, we need to make sure that that happens. Anybody else? All right, cool. Okay, so let's take a few minutes to organize ourselves. Why don't we have three? We got 6 tables here, so we can set like the immersion up on these 2 tables, and Jacob, you can kind of take these middle 2 tables to work on your heat door, door heat exchanger, and I can work over here with the kind of the direct cooling and we kind of take it from there. So if everybody kind of take a second.
Reorganize, regroup.
Yep.
For these two gentlemen.